Subscribe and download over 1 million code snippet including this tutorial from codegive.com, link in the description below. Title: Understanding and Handling Python Segmentation Faults, Core Dumped. A segmentation fault in Python occurs when the interpreter tries to access a restricted area of memory. This can happen due to various reasons such as dereferencing a null pointer or accessing memory that has already been freed. When a segmentation fault occurs, the program is terminated immediately, and a core dump is generated. In this tutorial, we'll explore the causes of segmentation faults in Python and discuss methods to handle and debug them. Segfaults are critical issues that can lead to unexpected crashes in Python programs. By understanding the common causes and using tools like try-except-blocks, GDB, and Valgrind, you can handle and debug segmentation faults effectively. Regular code inspection and testing are essential to prevent and catch these issues during development. ChatGPT. Title: Understanding and Resolving Python Segmentation Fault, Core Dumped, Errors. Introduction. Python is a powerful and versatile programming language, but like any software, it is not immune to errors. One of the more mysterious and challenging errors that developers may encounter is the segmentation fault, core dumped, error. This tutorial aims to provide insights into what this error means, why it occurs, and how to diagnose and fix it. A segmentation fault occurs when a program attempts to access a memory location that it's not allowed to access. This could be due to various reasons, such as accessing an uninitialized pointer, dereferencing a null pointer, or overrunning a buffer. When the operating system detects such illegal memory access, it terminates the program, resulting in the segmentation fault, core dumped, error message. See extension modules. Compile and import this module in Python. Running the Python script will result in a segmentation fault. Buffer overflows. Enable core dumps. Analyze core dump. Check C extension modules. Review code. Use memory profilers. Title: Understanding and Resolving Segmentation Faults in Python with Code Examples. A segmentation fault, often displayed as segmentation fault, core dumped, is a critical error that occurs when a program attempts to access a restricted area of memory. In Python, segmentation faults are uncommon but can still happen, usually due to issues with C extensions or low-level memory management. In this tutorial, we will explore common causes of segmentation faults in Python, how to identify them, and potential solutions. We will use code examples to illustrate each scenario. One of the most common reasons for segmentation faults in Python is the use of C extensions or external libraries. When these extensions have bugs or memory access issues, they can lead to crashes. Example: how to identify. Solution: segmentation faults can also occur when there are problems with low-level memory operations, such as buffer overflows or invalid pointer dereferencing. Example: how to identify. Solution: segmentation faults in Python are rare but can occur when dealing with C extensions or low-level memory issues. Identifying the source of the problem and applying appropriate solutions are crucial for maintaining the stability of your Python programs. Always ensure your libraries and extensions are up to date, and carefully review code that involves direct memory manipulation to prevent segmentation faults. If issues persist, consider seeking help from the Python community or library maintainers. ChatGPT. A segmentation fault, often referred to as segfault, is a specific kind of error caused by accessing memory that does not belong to you. It's a mechanism that helps protect your program from corrupting its own memory space and causing unpredictable behavior. When a segmentation fault occurs, the operating system terminates the offending program by generating a core dump, which is a snapshot of the program's memory at the time of the crash. In Python, segmentation faults are less common compared to lower-level languages like C or C++, but they can still occur. This tutorial aims to help you understand and debug segmentation faults in Python with the help of code examples. C extensions. If your Python code uses C extensions, issues in those extensions may lead to segmentation faults. List indexing. Accessing elements in a list with an index that is out of bounds can result in a segmentation fault. Pointer dereferencing. If you are using types or other modules that involve direct memory manipulation, dereferencing a null or invalid pointer can lead to a segmentation fault. Before you start debugging, ensure that core dumps are enabled. You can use the following command to enable core dumps. After a segmentation fault, a core dump file will be generated. Analyze it with GDB. Then, use the bt command to get a backtrace. Consider the following Python script, segfault_example.py, that intentionally causes a segmentation fault. Run this script and observe the segmentation fault. Use the debugging techniques mentioned above to identify and fix the issue. Segfaults in Python are rare but can occur, especially when using C extensions or manipulating memory directly. Debugging segmentation faults involves enabling core dumps, using GDB, and analyzing the backtrace. Understanding the root cause of a segmentation fault will help you write more robust Python code. ChatGPT. Title: Understanding and Handling Segmentation Faults, Core Dumped, in Python. Introduction. Segmentation faults, often accompanied by the message core dumped, are critical errors that occur when a program attempts to access memory beyond its allocated boundaries. In Python, such errors are less common than in low-level languages like C or C++, but they can still occur. This tutorial aims to provide an understanding of segmentation faults in Python and how to handle them. Causes of segmentation faults in Python. Segmentation faults typically result from attempting to access invalid memory addresses. In Python, common causes include: A. Improper memory handling in C extensions or external libraries. B. Inappropriate use of pointers or memory in Python/C API calls. C. Bugs in custom C extensions or modules. Identifying a segmentation fault. When a segmentation fault occurs, the program terminates abruptly, and you may see a message like segmentation fault, core dumped, ... To identify the cause, follow these steps. A. Run the Python script with the GDB, GNU Debugger, tool. B. Within the GDB console, run your script. C. When the segmentation fault occurs, GDB will provide information about the error. Example code. Let's create a simple Python script that deliberately causes a segmentation fault. Analyzing the segmentation fault. Now, let's use GDB to analyze the segmentation fault in our script. A. Run GDB with the Python interpreter. B. Load your script in GDB. C. Start the script within GDB. D. When the segmentation fault occurs, GDB will provide information about the error, including the location in your script. Handling segmentation faults. Once you've identified the source of the segmentation fault, you can take the following steps to handle it. A. Review your code for pointer-related issues, especially in C extensions. B. Check external libraries for compatibility issues with your Python version. C. Consider using tools like Valgrind to detect memory-related problems. Conclusion. Segmentation faults in Python are rare but can still occur, often due to issues in C extensions, external libraries, or custom modules. By using tools like GDB, you can identify the source of the fault and take steps to address and fix the underlying problem. ChatGPT. Title: Understanding and Handling Python Segmentation Fault, Core Dumped, Errors. Introduction. A segmentation fault, often accompanied by the message core dumped, is a critical error that occurs when a program attempts to access a restricted area of memory. This type of error is not specific to Python. It can happen in any programming language, but Python's interpreter usually handles memory management well. However, in certain situations, particularly when working with C extensions or low-level operations, you may encounter a segmentation fault. In this tutorial, we will explore common causes of segmentation faults in Python and how to handle them. Run the script. If a segmentation fault occurs, you can proceed with identifying the cause. Inside GDB, run your script. GDB will provide a detailed backtrace when the segmentation fault occurs, helping you pinpoint the issue. Valgrind will provide information about memory leaks and invalid memory access. Review code and memory operations. Carefully review your code, especially areas involving low-level operations, pointers, and memory management. Ensure that memory is allocated and deallocated properly. Consider Python memory profilers. Use memory profiler tools, such as Memory Profiler, to analyze memory usage in your Python code. Decorate your functions with @profile and run the script. Run the script. By following these steps, you can identify and resolve segmentation faults in your Python code. Remember that segmentation faults often involve low-level memory issues, so patience and thorough debugging are essential. ChatGPT. Title: Understanding and Resolving Segmentation Faults, Core Dumped, in Python. A segmentation fault, often accompanied by core dumped, is a critical error that occurs when a program attempts to access a restricted or non-existent memory location. In Python, this error is not as common as in lower-level languages like C or C++, but it can still happen, especially when interfacing with external libraries or dealing with low-level operations. This tutorial aims to provide insights into the causes of segmentation faults in Python and guide you through identifying and resolving such issues. We will also include a code example to illustrate the concepts discussed. C extension modules. Segmentation faults can occur when using C extension modules or external libraries that interact with Python. These issues may arise due to memory mismanagement or errors in the C code. Incorrect memory operations. Manually managing memory using C libraries or types in Python can lead to segmentation faults if there are errors in memory allocation, deallocation, or access. Pointer errors. Incorrect usage of pointers, particularly when interacting with C code, can result in segmentation faults. Ensure that you follow proper memory handling practices when dealing with pointers. Core dump analysis. When a segmentation fault occurs, a core dump is often generated. Analyzing the core dump with tools like GDB, GNU Debugger, can provide valuable information about the location and cause of the fault. Debugging tools. Utilize Python debugging tools like PDB or external tools like Valgrind to identify the source of the issue. These tools can help trace the execution flow and pinpoint the problematic code. Check external libraries. Ensure that any external libraries or C extension modules used in your Python code are compatible with your Python version. Updating or reinstalling these libraries might resolve compatibility issues. Memory management. Double-check your memory allocation and deallocation routines, especially when interacting with low-level operations. Use Python's memory management features whenever possible to minimize manual memory handling. Pointer safety. If dealing with pointers in C code, validate pointer usage and ensure that they point to valid memory locations. Avoid accessing memory beyond the allocated space. Use Pythonic approaches. Whenever possible, use high-level Pythonic approaches for operations to reduce the chances of memory-related errors. Python's built-in data structures and memory management are designed to be safe and efficient. In this example, the faulty underscore function attempts to access the value at the memory location pointed to by a non-pointer, leading to a segmentation fault. Understanding and resolving segmentation faults in Python involves careful inspection of code, proper memory management, and the use of debugging tools. By following best practices and leveraging Python's high-level features, you can minimize the risk of encountering segmentation faults in your Python programs. ChatGPT. Title: Understanding and Resolving Segmentation Faults in Python with Code Examples. Introduction. A segmentation fault, often displayed as segmentation fault, core dumped, is a common runtime error that occurs when a program tries to access a restricted area of memory. In Python, this error is typically associated with C extensions or low-level operations. This tutorial aims to help you understand what segmentation faults are, why they occur in Python, and how to troubleshoot and fix them. Overview of segmentation faults. Causes of segmentation faults in Python. Troubleshooting segmentation faults. Example code. Let's consider a simple example that demonstrates a segmentation fault in Python. Running this code will result in a segmentation fault. Now, let's debug it. Use GDB to identify the issue. GDB will provide a backtrace indicating where the segmentation fault occurred. In this case, it's due to accessing memory using a null pointer. Fixing the issue. Conclusion. Understanding and resolving segmentation faults in Python requires careful analysis of the code, debugging with tools like GDB, and fixing the root cause of the issue. By following the steps outlined in this tutorial, you'll be better equipped to troubleshoot and resolve segmentation faults in your Python programs. ChatGPT. Title: Understanding and Resolving Segmentation Faults in Python, a Comprehensive Guide. Introduction. Segmentation faults, often accompanied by the message core dumped, are critical errors that can occur in Python programs. These errors indicate a memory access violation, where a program attempts to access a region of memory that is not allowed. In this tutorial, we will explore the common causes of segmentation faults in Python and provide solutions to diagnose and fix them. Understanding segmentation faults. A segmentation fault occurs when a program tries to access a memory location outside its allowed range. This can happen due to various reasons, including dereferencing a null or uninitialized pointer, accessing freed memory, or overrunning a buffer. Common causes of segmentation faults in Python. A. Dereferencing null or uninitialized pointers. To fix this, ensure that pointers are properly initialized before use. B. Accessing freed memory. Avoid accessing memory that has been freed. C. Buffer overflows. Ensure that you do not exceed the bounds of arrays or lists. Using GDB for diagnosis. The GNU Debugger, GDB, is a powerful tool for diagnosing segmentation faults. Handling segmentation faults in C extensions. If you're using C extensions in your Python code, a segmentation fault might originate from there. Analyzing core dumps. When a segmentation fault occurs, a core dump file is often generated. Analyze it to pinpoint the issue. Memory profiling with mprof. Use the prof tool to profile memory usage in your Python script. Conclusion: segmentation faults can be challenging to debug, but with proper tools and techniques, you can identify and resolve the underlying issues. Always pay attention to memory management, pointer dereferencing, and array bounds to minimize the risk of segmentation faults in your Python programs. ChatGPT